Now that we have configured ASP.NET Core Identity, we have what we need to start implementing support for authentication in our REST API. We will begin by implementing an endpoint for registering new users and persisting that inside of Identity and inside of our applications database. So let's jump into the code and I will show you how we can build this. The first thing we have to discuss is where do we place this new endpoint. One option could be in the user's controller. We could expose some sort of post endpoint for registering a new user, but we would have to bring in a dependency to ASP.NET Core Identity as part of the user's controller, which is something I want to avoid. So my pragmatic decision in this case will be to define a separate controller for managing our authentication endpoints. We will also host the login and refresh token endpoints in the same controller in our upcoming lessons. So let's start by creating this new controller. I will add a new class, and I want to call it auth_controller. I prefer using the short name instead of specifying authentication, but if you want to, go ahead and use the full non-abbreviated name. Let's implement the controller base class, and I want to decorate this with the API controller attribute. Then when it comes to the route, I want to use auth as the base route for this controller, and then we will append a separate part to the URI for each of our endpoints. Also, when it comes to authentication for this controller, I want all of these methods to be publicly available. So I will decorate it with allow anonymous. Next, what are the services that we will need to implement support for registering users? ASP.NET Core Identity comes with a couple of service classes that you can use for user management. So you have to inject the user manager type and specify your user type, which in our case is identity user. So let's call this the user manager. Now this only allows us to interact with our users table. We will also need the application database context to persist our new user in the dev habit users table. But remember that we are also storing this in the identity tables, which is managed by our identity database context. Now, when you are using entities in two different database contexts, this could end up being two different database transactions. And this is something I want to avoid. So I'll show you how we can implement sharing transactions between two database contexts, and note that this only works because we are using the same database under the hood. If they were using different databases, and by this I mean different physical databases, then we would be dealing with a distributed transaction and we would have to resort to some different solution. So let's go ahead and define our new endpoint. It will be HTTP post, and I want to add register to the URI. Then let's make our method async. It's going to return a task of iActionResult, and let's call it register. Then we will need some DTO to bind the request body. Let's go ahead and create this DTO in the DTOs folder, where I will create a new folder called auth. Inside of this folder, let me create my first type, and let's call this the register user DTO. When it comes to the properties of this type, I will keep it simple. Let's say I need an email and I want this to be a required field. And then I need a couple of more string properties. So I will need the user's name so that I can persist this in the respective column in the database. And then we will also let our user provide a password and a confirmation password so that we can make sure that the register request is valid. Now that we have our DTO, we can use it in the register endpoint. So let me specify the registered user DTO and let's give it the name. So let's take it step by step and see what we need to implement inside of this endpoint. We will first need to create and register our identity user. After that's done, we'll need to create the application user. And finally, we can return from this endpoint. And for example, I'll return a 200 OK result. So let's tackle the identity part first. I need to create an identity user. So let me make a variable, initialize a new identity user type, and basically what I want to set here is the email and the password of this user. Both of these values are present on the register user DTO. After I have the user, I can say await user manager, create async, and then pass in the identity user instance. Now another argument for this is the user's password, which is available on my DTO, so I'm going to provide it. Now this method can fail, which is why this returns an identity result that you can check to see if the user registration was successful or not. Let's check if this result is successful. There's the succeeded flag that we can use for this, And if this is not successful, then I want to return some sort of bad request response. Now, because this should be a problem detail, we can return a problem response, and we want to describe why the user registration failed. So let's specify detail and provide a message like unable to register user. We can also say please try again. For the status code, I'm going to use 400 bad request, even though some other status codes might be appropriate, and this is because I don't want to inspect the identity result to figure out the specific reason why registration failed. This could be some validation problem with the incoming DTO, or it could be some internal reason why we can't register a user. I also want to provide an extensions dictionary, and let me initialize a new dictionary where the key is a string and the property is an object type, and I want to provide a key and value pair where I will specify the errors, and then the value will come from the identity result, where I want to project the errors into a dictionary containing the key value pairs. Now, because this is too cumbersome to place inline, let me define a new variable. Let's call it extensions, and then let me define my key and value pairs. So the key is just errors, and then I'm going to project this to a dictionary by selecting the code and then the description as the value. So now, if the identity result isn't successful, we will return a problem details response. If we manage to get to this line of code, then it means that our first step was successful, and we can proceed with registering the user inside of our application database context. For this step, I need to map from the register user DTO into my user entity. So let me create my helper type that will contain the respective mappings, and I'm going to add it in the users folder where all my mappings are. So let's call this the user mappings, and this will be a static class, and I need a public static method returning a user instance, which I will call toEntity, and this will be an extension method on the register user DTO. Let's call this the DTO, and we want to return a new user instance where we're going to set a couple of properties. First, the user's ID will be a complex value where I specify lowercase u as the ID prefix, and then I'm going to specify a version 7 UUID. The name will map from our DTO, so will the email, and I can set when this instance was created by using the current date and time. This is what we have available on the register user DTO. So now I can say register user DTO to entity, and we get back our user instance. A very important step here is to set the identity ID of this user, and this value will come from the identity user, and I'm just going to set the ID property. Then I can say application DB context users and add my new application user, and finally I can persist this by saying application database context save changes async. And then, just for the sake of testing, let's return the user's ID as the result of our endpoint. We're going to update this in our next lessons to return a JSON web token and the refresh token pair, but this will be enough to test out our user registration. Now, we do have a couple of more problems here that we have to solve. I already mentioned that we are using our application database context, but the user manager is also performing database operations, and this will depend on the identity database context. So we have to wrap this in some sort of transaction, otherwise these two calls, creating a user and persisting our application user here, may run in separate transactions, and this risks introducing some nasty data inconsistency bugs, which I definitely want to avoid. So let me show you how we can do this. At the top of our method, I'm going to create a new database transaction, and I will use the identity database context to achieve this. I can say identity database context database, this is the database facade, and I can say begin transaction async. Because this is an async method, I will await it, and this will give me back an IDB context transaction. Then, after completing all of the work, I'm going to say transaction commit, or we can say commit async, but this doesn't make sure that the application database context is aware of the current transaction that we created. So we have to tell it explicitly. Now, this will also require my two database contexts to use the same underlying connection. So I can access the database facade and call the setDBConnection method, and I can get the connection value from the identity database context. We have to call the getDBConnection method. So now they are using the same connection, and I just have to make this context aware of the database transaction. So I can say application database context, database use transaction, and pass in the transaction instance. I can also use the async overload, and I need to say transaction get db transaction to pass in the correct instance. So now both of my database contexts are using the same transaction, and when I commit the transaction at the end of this method here, we will persist all of the changes in both of our databases. If we don't call commit async, our transaction will go out of scope and automatically roll back any changes that were made as part of the transaction. So now we should be ready to start our application and test out our implementation. Inside of my Postman collection, in the auth folder, there is a request to register a new user, log in and obtain an access token, and exchange a refresh token for a new access token pair. For this demo, we will only need the register request, and here's the request body that I want to send to my API. The route is auth/register, so this is the URI of the resource that we are exposing on our RESTful API. If I send this request, we will get back a 400 bad request response saying that the API is unable to register a user and please try again. But if I take a look at the errors extension, I can see the specific reason why this request failed. The password is too short, the minimum length is 6 characters, and the password requires a non-alphanumeric field. So let me update this request to satisfy these requirements, and then let's send the updated request. We will land on the breakpoint that I added in the auth controller, and let's walk through these steps that we have here. First, we will create our database transaction and then share it with the application database context. Then we're going to create the identity user and persist it in the identity tables using the user manager. So you can see this part will succeed, and we proceed to create a new user entity, set the identity ID, which will connect the users in the application schema and the ASP.NET Core users in the identity schema. Then we add this to the database context and call save changes. And finally, after we commit the transaction, all of this is persisted inside of our database. So I will press continue, and you can see that we get back a 200 OK request. And let me grab this ID value and see if a user with this ID exists. In the users folder, there is a request to get the user by the ID, and I can specify the ID value and send a request, and I will get back a 200 OK response which contains my user's information. Now, I purposefully omitted the identity ID because it's not relevant for the representation of this resource, and this is the URI that we will use to construct our API requests. Now, what will happen if I send another request to register the user with the same email? So let's send the request, and we get back a 400 bad request response saying that we are unable to register a user, and the specific reason is the duplicate username error. Now, you may or may not want to include this information in the response. Typically, this is considered a security concern because you tell attackers which emails are taken, which opens up some attack vectors. So you may want to sanitize the response that we are returning from this endpoint. I also want to show you the distributed trace for when we successfully registered a new user. You can see that we are sending quite a bit of database requests here. If we examine the SQL for each of these traces, you can see we have a lot of requests that are being sent by identity, validating if a user with the given username exists. Then we have a save point for our transaction. Here's the insert into the ASP.NET users table. Then we have another save point, Then we have an insert into the users table in the dev habit schema. This is our application database context. And finally, we are releasing the save point and completing our transaction. So you can see that inside of one request, we have quite a few requests that we are sending to the database. So this is something to be aware of. And I've noticed that ASP.NET Core Identity tends to be particularly chatty when it comes to talking with the database. I will wrap up my implementation here, but a couple of more remarks about what's missing. We could add support for validating the input DTO, the register user DTO, and we can implement support for confirming that the password and confirm password match. We can also implement some security rules for the password strength. And in this case, I'm not concerned with implementing a uniqueness check on the email because this is something that Identity will take care of under the hood. And I also have unique indexes inside of my database, making sure that I don't end up with duplicate emails. So this is how we can implement support for registering users using ASP.NET Core Identity. Now we have to extend this to add support for getting back an access token. And this is what we are going to cover as part of our next lesson, where we will implement support for token-based authentication, creating a JSON Web Token, returning that as a response, and using it to authenticate with our REST API.